Delay lines are fundamental blocks for many audio effects and synthesis algorithms. Here we have a delay line block diagram where we have an input signal xn and the output is the delayed version of xn by m samples. So a delay by m samples can be written as a multiplication of the signal x of n with z to the power of minus m in the z domain. So here are the equations for this multiplications of the signal x of n with z of minus m in the z domain, and we have this substitution that n prime is equal to n plus m for causal systems. This delay can also be seen as a convolution with the following impulse response in the time domain. So here's the impulse response, and we have m zeros and a 1, so meaning that hn is equal to 1 for n equals to m and 0 elsewhere, and here is in the form of a convolution sum. Here we're going to calculate the frequency response of a delay line when m equals to 3. So here we define our delay operator or our shift operator. So we have 3 zeros and then a 1. And the frequency response, we're going to use SciPy signal to calculate with the frac-z. And here we will plot the magnitude of the shift operator of the delay line, and here the phase. So we have a constant magnitude equals to 1, so we don't have any changes in the magnitude, and we have linear phase for this delay line or this shift operator.